to tell you a little more story, that we have a coordinate system like this. I'll draw it there to make it more clear. I have a coordinate system like this, suppose say, and this is one of my coordinate system, and we have another coordinate system like this. This is one, and I have another coordinate system here, suppose say, so this is my another coordinate system, and maybe the same coordinate system. I'll show you some changes here. Now suppose say this is what we have. We let's name this as A. This is A. Suppose this is A, this is B, this is C, and this is G. Now I make a shift of 90 degree of this coordinate system. When you say coordinate system, they suppose that let's take a right angle triangle here, and this is my point P. Like the previous lecture, we found P is the point where you find out x and y, or r and theta. We also find out r and theta in this. Now I shifted 90 degrees, so A comes here, B goes there, C comes here, and D comes here. The triangle, of course, changes like this. It becomes like this. This is P. It remains x and y, but I'm not mentioning it right now because we know the story. So ultimately, in this triangle, let me give one more thing here. This part is nothing but y, and this is x. And for this triangle, the other one we had, so for this triangle, the 90 degree one triangle, this part is y, and this part is this part is y, and this part is x. If so, then in this right angle triangle we found sine theta, considering this to be theta. So if we consider this to be theta, we can say sine theta is equal to y by r, because this is r, y by r. So if we consider this to be y by r, so let me rewrite this clearly. This is r. So y by r, I can rewrite this as y is equal to r sine theta. On the other hand, I can take this right angle triangle. Similarly, this will turn to cos, because 90 minus theta. So I can say cos theta, in short, is equal to x by r. So that leads to an equation, x is equal to r cos theta. So we have very clear equation here. One is y is equal to r sin theta, and x is equal to r cos theta. If I square both of this and add them, so if I square this and add this, this is also square, this is also square, this will lead to x square plus y square is equal to r square, and here we have sine square theta plus cos square theta, which is nothing but equal to 1. That means this is equal to r square, and this is equation of a circle. X square plus y square is equal to r square is nothing but equation of a circle. If we have this case, when we have a circle, so in my first lecture, if you remember, I consider this to be a point, and we consider this is nothing but a circle, and we refer this as trigonometrical circular function. What is wrong in that? We proved this, that with sine and cos changes, you call it a circle. So this is going to be circular function, and we also later I'll show how we can show this to be elliptical or parabolic, depending on the changes in the equation. That means Trigonometry is the link between x and y and r and theta. It is Cartesian coordinate system and polar coordinate system. So this is the link between trigonometry is link between them. And that is fine. Now we have changed this a and b. A has come in place of b and b has come in place of c, and so on and so forth. If I superimpose these two, this is actually showing you sine function, and this is showing you cos function. If I superimpose this, so we get a new style, we get a new coordinate system, which is nothing but, I can redraw it. This is a and a, this is makes a dash, and this is another, I can say this to be nothing but superimposition of both. So this is my a and this is another a, and this is b, another b. So I can simply say this is a, and this is the first, ये साइन वन a and ये साइन वाला a है, ये cos वाला a है. So दोनों के resultant like a vector quantity. I didn't discuss till now those concepts, but you know, if two forces are acting two perpendicular to each other, resultant will be at 45 degrees. Now just see, we have a circular function in this. So sine is also circle, cos is also circle. What about these? These are nothing but tangents to these circles. So we call it tangent function. What is known as tan function. So we call it tangent function. Whatever mathematical values are evolving is nothing but the ratio of sine and cos in both the cases. So this is all about our trigonometrical functions. We are further going to go for implementations of trigonometry. My next lecture will be typically on vector, and I hope you understood. And please give me feedback in my email so that I can make out you are coming with some doubts, or you can give comments also for my improvement. I always try to improve. Somebody requested me to speak only in English, so today I tried because I'm comfortable in that. But Hindi some of the students request. My topic is physics, not Hindi or English. अगर आपको कोई दिक्कत हो रहा है समझने में तो please tell me, otherwise my hard work will be of no use. Thank you.